Hello, thank you so much for joining this comprehensive course on Node.js. I am delighted to have you here. Node.js is an incredible platform for building high-performance, real-time networked web applications. And the really exciting part, you write your code in JavaScript, perhaps the world's most popular computer language. Node.js was created by Ryan Dahl back in 2009, and it's currently maintained by Joyent. Unlike web programming languages like PHP, Node is a platform which uses JavaScript as its programming language. This effectively means that you have to write code that gives you full control over your app logic and the serving environment within which it has to operate. This lets you do some really cool things like write chat servers, collaborative multi-user apps, real-time games, data streaming servers, APIs for mobile apps, and basically apps that require a high degree of concurrent users accessing input and output. Node's unique ability to provide non-blocked I/O makes it perfect for apps that require a high degree of scalability with basically a persistent connection to the server. In its fundamental design, Node.js is based on the highly popular Chrome V8 JavaScript engine by Google. V8 runs inside the Chrome browser and Node.js implements V8 on the server. Node works through an abstraction layer known as libuv, which enables Node to perform seamless input-output operations in a non-blocking way. In addition to that, a core library provides functions and methods that developers can use to write programs using JavaScript. So what sets Node.js apart from other systems and platforms is in its native ability to provide evented and non-blocking I/O. To understand an evented non-blocking system, let us first examine how a program written in a traditional synchronous and blocking way would work. Here, we have a program that is supposed to fetch the names of users and display them on the console along with the string hello users. When we run this program, the first line gets executed and invokes a method called getUsers, which runs a query on a database. The interesting thing to note here is that the database query in this case would effectively block and hold up execution of the remaining script. Once the result is received back from the database, the rest of the program would execute and you would get the output on the console. So effectively, the execution is sequential and synchronous. For printing hello users, the preceding two tasks have to be completed first. In synchronous code, therefore, to handle a large number of concurrent requests, multi-threading is often used. Hold that thought for a moment though. In contrast, let us see how an asynchronous execution such as in Node.js would look like. In this case, we have the exact same objective to the code we saw earlier. When we run this code, however, the method dbQuery sends off a request to the database in a non-blocking call to the event loop, a construct that is monitoring for events and messages in the V8 JavaScript engine. It's non-blocking, so it does not halt the execution of the script, and we immediately see a hello users printed out at the console. When the database server returns the response to the query, a part of the dbQuery method known as a callback is executed, which then displays the result. This way, the script never blocks itself. To put it in perspective, all I/O is managed by the event loop without blocking other tasks, thereby achieving optimum concurrency, a necessity when writing real-time networked apps. Instead of doing things sequentially, we do them in an asynchronous fashion. To sum up, the V8 engine inside the Chrome browser uses the event loop to monitor for user clicks and interaction, whereas on the server, the event loop in Node.js monitors for server events such as database query responses, network I/O, file I/O, etc. This makes Node.js extremely efficient and one of the major reasons why developers are excited about using it in their projects. But Node.js is single-threaded and my server has got an 8-core processor. In the traditional programming paradigm, concurrency is typically handled by multi-threading. Here is how it works. Whenever an I/O request is received, a multi-threaded system spawns a new worker thread which handles the request. The worker thread that is spawned blocks execution till the response to the I/O request is not returned. In this visual representation, the green zones represent activity, whereas the red zones are when the CPU is simply waiting for an I/O response. These red zones are when the CPU cycles are idle and effectively wasted, as they are blocked till the I/O returns a response. Additionally, if all workers are busy, further requests would be denied. If your app requires heavy I/O, then this may not be the best way out. In contrast, Node.js uses the concept of an event loop as mentioned earlier. An event loop monitors for events. So when we need to do I/O, we send our request to the event loop. Therefore, while a response to an I/O request such as a database query or even something as trivial as uploading a file is awaited, the event loop uses the time in between for other tasks, thereby keeping the process non-blocked and available for other constructs in the program to use. This way, it achieves efficient concurrency in a single thread. When response to an I/O request is received, it goes back and executes the callback code that processes the data as desired. Another thing you need to know is that in Node.js, unlike let's say in PHP or Ruby, you build your own stack. And that means writing a server, the app logic, and binding it with a data store like a MySQL database, or preferably to a non-SQL database like MongoDB. The fact that you have to first write the code which acts as a server is unique and sometimes difficult to comprehend for most developers coming from PHP, Ruby, or ASP.NET environments. But as you'll soon see, it's really easy and extremely powerful to be able to do that in the first place. Imagine your own stack from the ground up. So let us try and sum up some of the reasons why Node.js is great. Node offers several advantages by providing a unique event-driven non-blocking approach to I/O. This is paramount to modern web apps that need to serve an extremely high number of concurrent requests. You also get full control over your environment because you build your own stack from the server code up. This enables you to get full control over everything from a completely different level altogether. You write your code in JavaScript, an expressive and popular language, and consequently you also gain advantage from the exponentially growing number of users, companies, and the community which has embraced Node.js with open arms. Some of the biggest users of Node.js in production include Microsoft, Yahoo, eBay, LinkedIn, PayPal, and Walmart. I am also gonna quote a few paragraphs from an interesting article written by Kian O. Maiden. In this article, Kian sums up some of the reasons why Node.js is going to be the go-to technology for enterprises. One of the first reasons he writes about is how developers are really happy to embrace Node.js since it's new and pretty awesome. Kian quotes Bill Scott, Director of User Experience at PayPal, who says, and I quote, "Why go to Facebook and do PHP when you can go to PayPal and do Node.js?" I think that pretty much sums up how developers are looking at Node.js. On the subject of performance, Kian shares encouraging facts. He quotes a case study where Walmart was able to manage about 200 million concurrent mobile users during the 2013 Black Friday period using Node.js. And all this while the server's CPU utilization stood below 1%. This is just amazing, isn't it? Similarly, Groupon implemented Node.js and had their page load times go down by half instantly. LinkedIn was able to cut down the number of servers managing mobile traffic from 30 to 3 when they moved from Ruby on Rails to Node.js. Another very interesting point that Kian writes about is the fact that Node.js code is easy to maintain and modify since a Node.js app is composed up of small modules. Therefore, a large application is broken down over several modules, making it easy to upgrade and manage. And finally, something worth pondering is the fact that at PayPal, developer productivity skyrocketed when they moved to Node.js. I'm sure you don't need any more reasons to get excited about Node.js. So why not we get started with it?